Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 1, Probability, brought to you by Vitan Sir. In the last tutorial, we completed the questions number 6 to 10 of the exercise 1.4. This time, I'm going to complete the remaining questions and end this 3 tutorial long exercise. Okay. That is exercise 1.4 continued. Of course, the question number 11 will be there. If two balanced dice, they like these dice so much, are thrown simultaneously, then find. But before we find, let us draw the favorable, total outcomes of the dice here. You, okay, I'm just going to skip ahead. Of course, knew all those things, right? Yeah. So this is how you draw the total outcomes of a dice with perfect shapes. The questions given, I am just writing them down here for the reference. First question, at least one dice shows number 5 and number 2. First shows 5 or 6 and second show even number. Now, if I want to make these calculations very easy, I can just do away with the law of multiplication and law of addition, and I will just forget them all and I will just directly do the number. But the textbook people and the board wants you guys to make these answers very complicated with the use of the law of multiplication and the conditional probabilities and the independent events, and so I will have to follow those things. So rather than just answering them in a single line, for example, at least one dice shows number 5, so just take all the outcomes in which at least one has a 5 and divide them by 36 and you will get your answer. But no, textbook people don't want that. Second question is first shows 5 or 6 and second shows even number. So just take those 12 events in which the first one has 5 or 6 and then take the events in which there are even numbers. Okay, you will get 6 events and the total are 36. 6 upon 36, the answer is that. But textbook people don't want that. They want you guys to struggle hard. So I will show you guys how to struggle hard. Okay, so let's move on to those struggling questions here. I will start with the first answer, that at least one dice shows number 5. That means it's a union of events. Now, which event? So I am naming the event A, that first dice show number 5. So of course there will be 6 outcomes where the first number of dice 5, that is 5 1, 5 2, 5 3, 5 4, 5 5 and 5 6. Event B, where the second die shows the number 5, that will be 1 5 2 5 3 5 4 5 5 5 6 5, 6 events. And then there is the intersection of event, because there is at least one, which means I need to find a union of the two events, for which I will need the intersection of the two events, that the both dice show number 5. That's just 1, because 5 5, that's the only outcome here. So now I will start with calculating the probability. The total outcomes are 36, that I already know. The probability of event A is 6 upon 36, probability of event B is 6 upon 36, and probability of event A intersection B is just 1 upon 36. Quite easy. Moving on with probability of A union B, that is A plus B minus A intersection B. A is 6 upon 36, then 6 upon 36, then 1 upon 36. LCM, I have already not simplified it, so LCM is not a good, I don't have to take an LCM here. 6 plus 6 minus 1 is 11 upon 36. Did I not just tell you guys the answer? 11 upon 36 after this much labor. Okay, let's follow along with the textbooks right now. Moving on to second question. First shows 5 or 6 and second show even number. And so it's an intersection of events. Now first let's clarify that event A, that first dice shows number 5 or 6. Though if it is showing number 5, then there are 6 events, and if it is showing number 6, then again there are 6 events. So there are total 12 events in which the first die will be either 5 or 6. So there are 12 events. And event B, that the second dice shows even number. So there are 18 events in which the second dice show even number. How did I calculate this? Which are the even numbers? 2, 4, 6. So 1, 2, 1, 4, 1, 6. 2, 2, 2, 4, 2, 6. 3, 2, 3, 2, 3, 4, 3, 6. 4, 2, 4, 4, 4, 6. 5, 2, 5, 4, 5, 6. And 6, 2, 6, 4, 6, 6. 3 events times 6 are 18 favorable outcomes. Now you must remember that events of a first die and events of a second die are totally independent events because they don't depend on each other. It doesn't matter whatever number we got on the first die, when we throw the second die, it doesn't care about the first die at all because they are two different dies. So because event A and B are independent, we are going to use the law of multiplication for the intersection of events of independent events, where A is 12 upon 36, that is 1 upon 3. Event B is 18 upon 36, that is 1 upon 2. And event A intersection B, where first shows 5 or 6 and second shows even number, that is A intersection B, that is A into B, that is 1 upon 3 into 1 upon 2, that would be 1 upon 6. Didn't I just tell you guys in the beginning that it's 6 upon 36, that is 1 upon 6. So easy as that. Why do these guys make them so difficult? Anyhow, we have to follow what the textbook suggests us to follow, because if you don't follow them, your marks will be cut. Nothing major will happen, of course, in your life, just your marks will be cut. That's all. Moving on with the next question. Question number 12. A problem in mathematics is given to Tanya, Kathan and Kirti to solve. The probability of them solving the problem correctly, okay, of course correctly, are 2 upon 3, 3 upon 4 and 1 upon 2 respectively. We have to find the probability that the problem is solved correctly. That means the problem is solved correctly. Now basically, because we just have to find that the problem is to be solved correctly, it doesn't matter who solves the problem. All three solve the sum independently, of course, because no one, they are so honest children, they don't even pick at each other's notebooks to see how the other one is doing. So all of them are solving the sum independently, so their events of solving sum, I will name them ABC, are also independent events. So event A, that Tanya solves the sum, is PA, that is 2 upon 3, already given. Similarly, event B, that Kathan solves the sum, is PB, that is 3 upon 4. And event C, that Kirti solves the sum, that is PC, is also 1 upon 2. Now what we are supposed to calculate is that the sum is solved. It doesn't matter who. That means at least one of the three must have solved the sum. That means at least one of the three has solved the sum here. So again we are using the word at least one. At least one means union. But the difference here is this is a union of three events, not just two. It's going to be a long sum. Probability A union B union C, the grand formula: A plus B plus C minus A intersection B minus B intersection C minus A intersection C plus A intersection B intersection C. Now because these events are independent events, their intersections are the multiplications of themselves. So we are just going to multiply these events to find their intersections. A, B and C are available, we have to find their intersections only. So A intersection B will be A into B, that will be 2 upon 3 into 3 upon 4. Simplifying it will be 1 upon 2. Similarly, A intersection C will be A into C, that is 2 upon 3 into 1 upon 2. Simplification will be 1 upon 3. Then B intersection C will be B into C, that is 3 upon 4 into 1 upon 2. Simplification will be 3 upon 8. And last, A intersection B intersection C is A into B into C, that is 2 upon 3 into 3 upon 4 into 1 upon 2. The answer will be 1 upon 4. Now let us again write down A union B union C and then put the values here. Value of A, B, C, A intersection B intersection C, B intersection C, and plus A intersection B intersection C, that is 1 upon 4. Okay, now we can't do this like this, we have to find an LCM. So 3, 4, 2, 8, okay, 24 will be the LCM here. So 2 upon 3 into 8 will be 8 2s are 16. Of course, you guys are in 12th, you know how this happens, just do it yourself. So this is the LCM here, just add and subtract them and you will get 23 upon 24. So the probability that sum is solved is 23 upon 24. That means pretty much complete, pretty much certain that at least someone will solve the sum and the sum will be solved correctly. Moving on to question number 13. Person A can hit the target in 3 out of 5 attempts, whereas person B can hit the target in 5 out of 6 attempts. If both of them attempt simultaneously, find the probability that target is hit. Not the mosquito hit, the target is hit. Of course. So person A and person B are two separate persons. They are trying to hit the target separately. That means the events of hitting the target will also be the independent events. The dice were independent events, the persons were independent events, even the bombs thrown out of the aeroplanes will be independent events. Okay, they have not given us those questions yet, but okay, in advance, the bombs thrown out of aeroplanes will also be independent events. So whenever we are talking about sums in which 2 or 3 separate things working independently are given, consider them independent events, and that means you can just multiply those events to get their intersection of event here. So event A, that the person A hits the target, is 3 out of 5. That is upon, of course, the probability is 3 upon 5. It's the probability given directly. Then event B, that the person B hits the target, is probability of B, that is 5 upon 6. And the intersection, because we need to calculate that the target is hit. That means anyone can hit it. That means at least one has to hit it. That means it's a union of events. And for the calculation of union of events, we need the intersection of event. That is A intersection B, both hit the target. That is A intersection B, that would be, because they are independent events, A into B, that is 3 upon 5 into 5 upon 6, the answer is 1 upon 2. Now, because target is hit by at least one of the two, we have to calculate the probability of A union B, that is A plus B minus A intersection B. 3 upon 5 plus 5 upon 6 minus 1 upon 2, the LCM will be 30. So accordingly change the numerators and the final answer is 28 upon 30, that would be 14 upon 15. So the probability that the target is hit is 14 upon 15. I hope you guys are getting how we calculate these things here. After 13 comes the 14th question. Person A speaks the truth in 90% of the cases. Wow, 90% of the cases he speaks truth. Whereas person B speaks the truth in 80% of the cases. Great Atmas these people are. Find the probability that person A and B differ in stating the same fact. Now this is a question given in very short words, but actually when you think about it, it's a pretty big question. Why? To simplify it, if A speaks the truth, B must lie because they should differ. If A speaks the truth, B cannot speak the truth, B must lie. And the other option is, if A lies, then B must speak the truth. That means we have to combine so many probabilities here. Something like the previous tutorial, if I recall correctly. Let us start with the events, but before, let's clarify again that A and B speak independently. So the event that they speak truth are also independent events, and basically the events where they lie are also independent events. I explained that those things when I explained the law of multiplication. So there are two persons, so they are independent. Starting with event A, that A speaks truth will be probability 90% is 0.9, and then B speaks truth is 80%, so that will be 0.8. But I also need to calculate the probability of their lying. So lie is the opposite of truth, so I just have to calculate the complementary event A dash, that is 1 minus 0.9, 0.1. Similarly B lies, that is B dash, that is 1 minus 0.8, 0.2. Now once again I will write down what we are supposed to calculate, that A speaks truth and B lies, or A lies and B speaks truth. So I hope you guys can form your equations using this. A speaks truth, that is A, and B lies, that is B dash. So A intersection B dash, or means the union. A lies, that is A dash, and is intersection. B speaks the truth is B. So intersection is multiplication and union is addition because the events are independent. So A into B dash plus A dash into B. A is 0.9, B dash is 0.2, A dash is 0.1, B is 0.8. Just multiply them and you will get 0.18 plus 0.08 and the answer will be 0.26. So the probability that when there is a single fact which A and B are supposed to state, they will differ in their answers. That means A and B will not give the same answer, they will give different answers. The probability of happening of that event is 0.26. So I hope you guys getting that the probability is a chapter where you constantly have to use your brains. This is not a topic where you can just mug up the formulas. Of course you have to mug up the formulas, but then use those mugged up formulas very logically in the given question to find the probability. You are just lucky that the answers are given. Just think about the people, the statisticians who are actually calculating probabilities of very high level without actually knowing the answers. They are supposed to find the answers. So you guys are actually doing a lot of easy work. People have been working very hard in the life. I suppose I am giving too much of an advice to you guys right now. Let's just concentrate on our studies again. Last question of the exercise and this tutorial. If three events A, B and C are independent events and A point 2, B point 3 and C point 5, then find A union B union C. Now if you are thinking that okay, you have to again use the grand formula, then you have a good news. Let's use an alternate shortcut method for calculating the union of these independent events. Okay, I am going to give you a shortcut method of calculating these things in which you don't use A, B and C, rather you use their complementary events for the calculation. So A dash will be 1 minus 0.2, 0.8, B dash will be 1 minus 0.3, 0.7 and C dash will be 1 minus 0.5, 0.5. Okay, and A union B union C is to be calculated and I have calculated its opposite. So let's continue with the trend and calculate the intersection of these three complementary events. Okay, we are going total opposite here. So A dash intersection B dash intersection C dash, because those are independent events, it's just the multiplication of them, 0.8 into 0.7 into 0.5. The answer will be 0.28. Okay, yes my dear friends, the answer is 0.28. Now of course this is not the final answer, because A dash intersection B dash intersection C dash does not equal to A union B union C. Let's see how we can calculate this. Now according to what I explained in the very beginning of my video, the first or the second video, the various forms of the probabilities, in which one was A dash intersection B dash intersection C dash is A union B union C dash. Now I hope you guys understand the connection between the question and what I am doing right now. A union B union C is equal to 1 minus A union B union C dash. Now A union B union C dash is 0.28 already, which we have calculated. So 1 minus 0.28 and your answer is 0.72. Quite easy. Yes my dear students. So with this I am ending the exercise here. I have talked too much about other things in this tutorial. Maybe I was getting bored at home and I have given you some different formulas, or maybe I have given you some tricks to use when saving the time in your examinations. Be aware to remember those tricks and use them, practice them a lot. I will catch you in my next video with the last topic of the probability chapter, which has actually spanned over 15 tutorials, 16 tutorials already, and I will complete this chapter in remaining 4 to 5 tutorials only, so you will not have to bear with me a lot in this chapter. See you guys next time and stay tuned. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.